Good morning, good afternoon, and good evening, everyone. A huge warm welcome to this Frontiers in Science deep dive session on imperatives for reducing methane emissions. My name is Gilbert de Gregorio, and I will be your host today, and I'm the Associate Director of the Frontiers Planet Prize, and I'm exceptionally excited about today's event. So, a brief introduction to Frontiers in Science. This is our flagship multidisciplinary open access journal focusing on transformational science that accelerates solutions for healthy lives on a healthy planet. The journal publishes invited peer-reviewed lead articles within a hub of multi-audience content that's they're designed to extend their reach across science, policy, and the general public. And today's deep dive focuses on the lead article entitled The Methane Imperative that was published in July this year. And it's led by Professor Drew Shindell from Duke University in the US and has already been picked up by multiple media outlets, including The Guardian, Newsweek, and Earth.com. So about the article itself, methane is the second most important greenhouse gas driving climate change. Levels are rising fast. Especially since the beginning of this decade. And between 2010 and 2019, we've learned that total warming of 1.07 degrees Celsius was observed, of which half a degree was attributed to methane alone. Despite this, little action has been taken to reduce methane emissions, with most efforts continue to be focusing on CO2 mitigation. In their lead article, Professor Shindell and his colleagues highlight the faster than predicted rise in methane emissions, the reasons for it, and how this threatens our ability to limit global warming to 1.5 or 2 degrees Celsius. The article also outlines the three methane imperatives for reducing emissions. First of which is changing course and reversing methane emission growth, aligning methane and carbon dioxide mitigation, and finally, optimizing methane abatement options and policies. And the article itself provides analyses and a brand new online tool to help countries optimize cost-effective strategies for reducing methane emissions. So this is the article hub. It includes an editorial by Dr. Lars-Peter Richegaard, former director of the Global Greenhouse Gas Watch, and Dr. Oksana Tarasova from the WMO. We also have viewpoint articles by Dr. Andy Reisinger from the Institute for Climate, Energy and Disaster Solutions at the Australian National University, and by Dr. Fiona O'Connor from the UK Met's Office Hadley Centre and the University of Exeter. We also have a policy outlook by Dorrit Zelker, founder and president of the Institute for Governance and Sustainable Development. There's also a lay explainer for you to have a deeper understanding of the article itself, infographics, a video, and an article written in Frontiers for Young Minds, our journal for kids. So here's today's agenda. Firstly, we'll hear from the authors and the co-authors themselves. So we have Professor Drew Shindell from Duke University, who led the development of the article, and he will be setting the scene for today's discussion. We also have Tomas de Oliveira Bredariol from the IEA, who will discuss how we can turn these pledges into progress. We have Dr. Lena Höglund-Isaksson from the International Institute for Applied Systems Analysis, EASA in Austria, who will be exploring if we're getting the incentives for methane abatement right. And then we'll move over to a panel discussion with a live Q&A with the presenters and our guest panelists, who will be Martina Otto, Head of Secretariat from the Climate and Clean Air Coalition from UNEP, Professor Marcelo Mena Carrasco, the CEO of the Global Methane Hub based in Chile, and finally, Professor Euan Nisbet from Royal Holloway University of London, who was also the handling editor of this article. So without further ado, let's get started. I'd love to introduce our first speaker, Professor Drew Shindell, who is a leading physicist and a climate scientist specializing in the natural and human drivers of climate change. A few notes about Drew. He is the chair of the Climate and Clean Air Coalition, the CCAC Scientific Advisory Board. He also steers policy efforts to reduce air pollution and mitigate climate change. And he also chaired the 2011 UNEP and WMO integrated assessment of black carbon and tropospheric ozone. He was a coordinating lead author on the 2013 Fifth Assessment Report of the IPCC and the 2018 IPCC Special Report on 1.5 degrees. In his current role at Duke University, his research continues to influence global climate policy and promote sustainable environmental practices. So without further ado, Drew, a warm welcome. Thank you for bringing this article to Frontiers in Science, and the floor is yours.
Thank you, Gilbert, and thanks to all from Frontiers who've done such a great job setting up the article and now this webinar. Great to see so many names joining us, and I'm just going to jump right into explaining our article. Before I go into details about the article, I want to make sure that while we've got a couple of the co-authors here with me today, there were many more. We had a great team from all around the world, and this really was a group effort. Now, we organized the article because of its breadth into three main imperatives, and I'm going to go through those in order, but just to echo something that Gilbert just pointed out, in the last IPCC assessment, methane emissions were attributed to have caused about 0.5 degree of warming, and so that's a second most important greenhouse gas, and it's a big second. CO2 has caused about 0.8, so this is a big part of the puzzle of how we get to a low warming where we would like to be. And one thing that we first talk about in our first imperative is the imperative to change course, because we are not on track to limiting warming to levels consistent with the Paris Climate Agreement, unfortunately. If we look at methane, here are observations on the left from both ground-based and satellite data. We see that after a period when methane growth was essentially flat, around the turn of the century, since about 2007, we've seen not only a large growth rate year on year, but an accelerating growth rate where the values keep getting higher and higher and higher, with record levels in the early part of this decade. When we infer what the emissions were that are consistent with the observed growth rate, we find a jump, really a steady, well, not so steady, but an unfortunate increase, especially since, again, from about 2007, levels were around 560, 570 megatons per year, with a higher rate, more like 590 around the latter part of the last decade, and in this decade up into the 600s. That's not what we want to see to get us on track to actually lowering emissions and being consistent with Paris Agreement targets. In fact, when we compare here what our baseline predictions were in a whole bunch of integrated assessment models and bottom-up emissions inventories for the current 5-year period, the growth rate was, somewhere typically around 7 to 9 parts per billion, with a full range going all the way up to maybe 13 or so. 3 of the past 4 years have been at or above the maximum, even in our baseline scenarios, without further action. Down in the lower part of this graph, you can see that what we would need for 1.5 is we'd need methane to be coming down. Even in this first part of the 2020s, about 9 parts per billion decrease per year, increasing to almost 20 parts per billion decrease by the latter part of this decade. And so we're nowhere near on course when we're still accelerating quite rapidly and getting worse. So one of the imperatives is to really get our emissions going in the opposite direction from where they're going now. The ways we do that need to be consistent with our understanding that CO2 is the most important greenhouse gas, and methane is the second most important driver. So we really need a portfolio of policies that addresses both of these. One of the things we really tried to highlight in the article was how it's really quite useful to consider these things together, not necessarily to consider, how much we should do of one versus the other, but to look at the advantages of targeting both of these. And one of the reasons for that is, I'm going to start with the left-hand side here. When we look at climate change, as we decarbonize, which is essential to reduce our CO2 emissions. You know, the dirtiest fuel in terms of CO2 per unit energy produced is coal. As we phase out coal, we also phase out the co-emissions that go with it, especially sulfur dioxide and nitrogen oxides. Those are very short-lived. They come out very quickly. They cause cooling. So getting rid of those causes a small short-term warming. And eventually this turns into something, you know, crucial. By the middle of the century, we're on a trajectory where decarbonization is giving us these desperately needed reduction in warming, but it doesn't happen soon. In contrast, when you look at methane abatement, I'm showing two curves here. One is the methane abatement, the upper one that comes along with decarbonization, and the other is full methane abatement up to our technological and some societal change, giving us something 1.5 degree consistent. And what happens with methane is it is generally there are very few, if any, co-emissions. So we just reduce methane. That being a short-lived gas causes warming to decrease relatively quickly. It doesn't, the reason I show two graphs here is it doesn't really get you where you want to be just waiting for this transition to phase out fossil fuels. That's this upper reddish line. What we really need, therefore, and what we call for in the article is targeting methane while we are phasing out the use of fossil fuels. So we phase out coal very, very quickly in 1.5 degree scenarios. We do transition away from use of gas and oil, but that happens more slowly. And during that necessary transition away, it's very important to also minimize our methane emissions. Now, they don't just come from fossil fuels, but that is one of the big messages here. When we put them together, decarbonization and methane abatement, then we get on a trajectory something like this. So really targeting methane is a way to limit the near-term warming, to limit the overshoot that we'll see of something like 1.5, assuming we get our act together and actually do decarbonize. And it's a way to get reductions in the net effect of climate change to happen substantially earlier than they would with decarbonization alone. So these are really complementary. It's not one or the other. We need to do both of these things, reduce methane and reduce CO2. And some people have pointed out that, you know, well, methane is short-lived, therefore we could just put it off and deal with it later. Well, of course, people would suffer from the climate impacts, which are all too real to many of us around the world, being worse if we did that. But methane not only produces climate change, but it produces ozone down at the ground where we breathe it in, and it kills people. And that's what the right graph shows, is that in our analysis from the article again, if you put off methane abatement for, say, 20 years, like in this example, then you know you do get to a similar state of climate change, but towards the end of the century, but many hundreds of thousands of people would have needlessly died by having to breathe in this more toxic air along the way. Now, there's another link between methane and CO2 abatement, and that is that methane emissions, when we think of the carbon budget, those are already factored in, right? The analyses that look at how much carbon we can emit that's consistent with, say, 1.5 or 2 degrees, already assume that we are going to make major reductions in methane. And so every 50 million tons of sustained reduction that we don't make would take away a chunk of that budget. And the more we push down methane, the larger our carbon budget is to be consistent with a given warming target. When we look on the right, there's another point that really brings out the connection between methane and CO2, and that's that there are several sectors, things like steel and aviation, which are economic activities that are very difficult to decarbonize. And so all in our model scenarios to reach net zero, the main way we compensate for those difficult to decarbonize activities is through land-based carbon removal, and that's either afforestation or energy crops. And where do we get the land from? Well, here it shows the models for which we could find the data. Pretty much if you want a couple 100 million additional hectares to grow biofuel or to plant forests to take up carbon, in the models, this always comes from reduced pasture. If you're reducing pasture and you're having less livestock, this is a great way to also cut methane from the agricultural sector. The last imperative we talk about is the imperative to optimize abatement, because this is a challenging process, right? We're going to talk much more about that in the discussion, I hope. But there are many things that have to be done because of all of the different sectors, and they vary around the world. But there's something for pretty much every country around the world to take action. And, in some places like the dark blue here, Poland, Ukraine, China, Australia, coal mining offers the biggest abatement opportunities. In many others, in this light blue, it's landfills. In some countries, like in North America, it's oil and gas. In South and Southeast Asia, it's rice, right? There's something to do everywhere. And that means that we need action from countries all around the world, but they're not going to be the same actions. It's a much more heterogeneous picture than it is for something like decarbonization of fossil fuels. When we look at the options, though, there's some very good news here, I would say. Here's an example for coal, and China is off the charts here because their abatement potential is so high that we can't see the others if we look at it. But what these show are the top 15 countries where there is a large abatement potential, ordered by the cost. And the cost here on the left has been evaluated by the U.S. Environmental Protection Agency, on the right by IEA. And what we can see here is that there are some differences when you get down to exactly the order of the different countries. There are substantial differences in the costs, which often have to do with the methodology here. But in particular, many of these are very low price in terms of carbon reductions or carbon prices for the kind of things we're used to, especially in the analysis of the IEA. Many of these things have negative overall cost. And it's quite consistent that the largest three countries here are China, the United States, and Russia. So we have a fair bit of information on where we need to act. We know where the largest least cost mitigation options are. There is much still to learn, right? And I think we're going to learn a lot more over the coming decades because of this revolution in remote sensing capabilities in particular, which we will again hear more about. Now, if we turn to another example of the landfill sector, here we have an analysis from the US EPA. And again, this is really encouraging news, where the bars again show the abatement opportunities in the top 15 countries that are least cost with large amounts of abatement potential. And the numbers show the average cost. And so what we're seeing here is that, if you look like a country like the UK right in the middle, the average cost of abatement is minus $500 a ton, right? So this is terrific. This means you're actually saving money. And when you look at the two bars there, part of this comes from using the methane captured in landfills for energy generation. Part just comes from flaring it off. So that when you flare off methane, obviously that doesn't bring in any income. But when you use methane for energy generation, those are the ones that are giving you net welfare, so that they're paying for themselves, which means there's a subset of technological abatement options which are even much, much less expensive, so even more beneficial than the average shown here, because the average includes those that are more expensive as well as some of the less expensive ones. Now, it sounds like a simple story. Great, there are things that pay for themselves. And so here's an example of some analysis, which we'll hear more about from one of our co-authors, Lena, in a few minutes. But, you can find an abatement measure that pays for itself, like here, when gas and oil prices are high, there are some methane abatement measures that generate money, and yet they still might not be done, right? And so in this analysis, you can see that they might not be done because there might be another use of that money, which is even more generating even more profit. And the example that to show that this is what happens in the real world sometimes is, here's data from an oil field in Nigeria, which was owned by several of the major Western oil producers, who kept flaring very, very low for many years. And then it was sold to a private equity investment company who has no consumer presence, right? So they have no reputation to consider. They couldn't care less really what people think of them. The flaring volume went up to millions and millions of cubic feet just in a matter of a few weeks. And so this shows that while the technology may exist, and it may even be being applied in a particular oil field, If there isn't pressure to do this, sometimes the companies will just not use this, right? They will not use this technology, not because the technology is difficult, not because they don't have it, but because they can make even more money sending those people and those resources to do something else. And so one thing that we talk about in the article are ways to think about what would be the appropriate way to value limiting methane. And so we look at the methods that are typically used in the United States as part of our federal rulemaking, where we have a social cost of methane, which values the climate damages. But then there are also these damages from ozone and health, which have not been included in climate metrics in the past, but could be, and those bring up the value per ton greatly. If you think back to some of the charts that I showed previously with lots of small numbers, so just to remind you, even for something like coal, where the measures didn't always pay for themselves, depending on the analysis, they were often a few $100s per ton, which shows that from this perspective of thinking about social welfare, they are very, very well worth it. They're much less than the damages that are being caused. So I'm going to pass this back over to the next person. Thank you very much.
Thank you very much, Drew, for that really great introduction and sharing the 3 imperatives with us. So now I'd like to move over to our next speaker and co-author of the article, Tomas de Oliveira Bredariol, from the IEA, who is an energy and environmental policy analyst. A few words to introduce Tomas. He's an environmental engineer. He holds a master's degree in public policy strategy and development and led the analysis on methane emissions in the IEA's World Energy Outlook 2023 and the Global Methane Tracker this year. He specializes in analyzing and developing policies that promote sustainable energy and environmental practices. And prior to his arrival at the IEA, he worked as a policy officer in the Brazilian Institute for the Environment and Renewable Natural Resources. Tomas, thank you very much for joining us today. The floor is yours.
Thank you, Gilbert, and thank you, Drew, for a great overview. And thanks everyone for joining us from so many countries around the world. So Drew outlined a lot of what are the imperatives that we have, what we need to do. I want to go a bit deeper into how we can deliver progress. We have for many years seen growing attention now to methane emissions. There are now over 150 countries behind the Global Methane Pledge. Many of them have detailed action plans. There are a lot of different parts of the industry that are engaging in this, for example, through the Oil and Gas Decarbonization Charter. But as we've just seen, emissions are not coming down yet. So I want to kind of focus a bit on what we know, what we don't know, and what this all means in terms of delivering effective reductions in the concentrations of methane in the atmosphere. So let's start with what we know. We know that tackling methane emissions is a key opportunity to drive down overall greenhouse gases and limit near-term increases in temperature. There is large scope for fast and cost-effective methane reductions across the main emitting sources and regions. Drew already gave a few examples. I'm going to give a few others. Now, this has been gaining growing attention from policymakers, but it's not near enough. Recently, we've conducted some analysis, and it showed that translating methane pledges into nationally determined contributions would give a major boost to emission reductions in more than 60 countries that are signatories to the Global Methane Pledge. So there's still a lot of details that need to be sorted out, a lot of policies that need to come into effect to make sure that we deliver on the pledges that exist. And we know that there's not enough attention from capital holders. Less than 5% of global climate finance is estimated to go towards methane abatement, even if, as Drew was mentioning, methane accounts for about 0.5% of warming, CO2 for about 0.8, perhaps a bit more, but methane should be a much larger part of the conversation. Now, to illustrate this, here what you see are the main sources of methane emissions from human activities: agriculture, energy, and waste. There are also other sources, including from biomass burning, but these are the main ones. And we know that well over 1/3 of methane emissions could be reduced with available technologies within a short time frame. So let's say to 2030, to the end of the decade. And if we look at what is the abatement potential, we need to work on all of these fronts. There are effective measures to increase efficiency in agriculture, to reduce methane leaks in oil and gas facilities and coal mines, to capture gas from landfills and reduce methane emissions from waste. And the biggest opportunity is, at least on the near term, is in the energy sector. So let's come back a bit to the question of what we can do in this specific sector. Here we're looking at the figures for oil and gas from the International Energy Agency. And what we can see here is that on average, these are low-cost measures. So there are some projects that will need upfront spending, and even that in some cases, they will not be able to recover fully all the capital that is deployed. But for a large share of emissions, for 40% of all the emissions from fossil fuels today, these could be avoided at no net cost, because the spending needed to deliver these methane emission reductions could be recovered by the additional sales of natural gas that would be recovered through these same measures. So these are very well-known and readily available, tried and tested solutions, like deploying leak detection and repair campaigns in oil and gas facilities, or replacing leaky equipment such as pneumatics by alternative sources with no emissions, like electric devices or instrumented air systems. There are a range of options that could deliver very significant reduction in emissions, about 75% reduction in emissions, many of these at very low cost. So what we still don't know how much is being spent and where. So we understand that there's some amount of effort going into this, but there's a lack of data on financial flows. We don't know what is the size of the effort of different countries and companies that are working on this. And it's very hard to have a good overview so that we can better manage methane mitigation. And this relates to the second point, which are what are the key priorities and challenges. When we think about global level, the picture is very clear. But if you want to drill down onto specific projects and work on project identification, understanding specific costs and emissions, this is still very poorly understood. When you go down to a facility level, most of the facilities around the world do not measure their methane emissions. So it's very hard to identify what are the biggest sources and what are the biggest opportunities to reduce these emissions. And this links to the third and final point here, which is where progress is underway. To make sure that we deliver on these pledges, that we do achieve progress, we need to have better data in terms of measured emissions, to move from kind of this patchy data that we have nowadays and be able to really track progress year on year on different regions and different facilities to know where methane management is improving and where it is deteriorating so that we can act on it. Finally, let's move to what this means and what are some of the latest developments. And one big development that I want to highlight today is the improvement in methane data. Up until last year, we had mainly one very good instrument, Tropomi, delivering satellite observations. But these were very coarse level, right? We were talking about kilometers by kilometers of definition, methane emissions that are above often 5 million tons. So only very, very, very large leaks. And this is changing with new satellites coming online, such as Stavanger 1 from Carbon Mapper or MethaneSat from EDF. And here we see the case of a company that's been working on this for a couple of years now, GHGSat. And this will improve our understanding of emissions. And so what this all means is, first of all, there's no excuse to delay action. While the data right now is not perfect, we know many ways to reduce methane emissions now that don't depend on a perfect understanding of emissions. I gave some examples like leak detection and repair campaigns or changing leaky equipment. there are many others. We need that policymakers need to step in. Companies, they're not going to be doing that voluntarily, at least not to the full extent and at the pace and scale that is needed. We need policymakers to address the barriers to methane mitigation, be it infrastructure barriers or institutional barriers or economic barriers. There are many tools available for policymakers to address these barriers and deliver on progress. And this will be made easier by this better data that is coming on. Better data will help us track abatement efforts, improve the prospects of quick and effective methane mitigation, bring more transparency, enable financiers, banks, investors, civil society at large to engage with the sector and help to deliver methane reductions. Thank you. With this, I will hand it over to the next speaker.
Thank you very much, Tomas. That was really great to explore the key priorities and challenges about the data resolution for methane emissions, especially on a regional and a facility level. So that hopefully that's something that we can continue discussions during the panel and the Q&A. Speaking of which, if you have any questions, please don't forget we have the Q&A chat below. Post your questions and we can put this together to fuel the discussions after the presentations. So last and not least, I'm pleased to welcome our final speaker and co-author of the article, Dr. Lena Höglund-Isaksson from JASA in Austria. She's a senior research scholar and is renowned for research on air pollution, greenhouse gases, and climate policy, and has also developed the global methane module in JASA's GAINS model. And her research supports international efforts to address climate change, providing invaluable insights for policymakers. She also coordinates policy applications on mitigation strategies for methane and other non-CO2 greenhouse gases. And applications for this includes impact assessments from the EU in their energy climate policy packages and various global assessments, such as the Global Methane Assessment and UNEP's emissions gap reports, as well as IPCC assessment reports. That's a portfolio of very impressive efforts that you have there, Lena. So without that, I will now hand over to you. The floor is yours, and we look forward to hearing from you.
Thank you very much, Gilbert, and thank you, Tomas and Drew, for laying the ground for my presentation here, because what we have just heard is that there are plenty of low-cost opportunities to reduce methane emissions, and also even profitable opportunities. In particular, when methane abatement involves recovery of valuable gas that can be utilized as energy. So, if it is profitable to reduce methane emissions, why don't we see more of these opportunities being realized? To understand this, we need to look deeper into the assumptions behind such conclusions. And to start with, we can look at the cost perspective used, because whether profitable or not depends in part on who you ask. Usually, the cost perspective of society is used in integrated assessment models when the objective is to find the emission reduction target that would be optimal for society's overall welfare. And this assumes a very long time horizon spanning several generations, a relatively low discount rate reflected as a low interest rate on investments, and considers also expected future increases in energy prices as well as technological development. And under these assumptions, methane abatement costs come out on the lower side, or even turn negative, meaning that they become profitable. While this is the appropriate cost perspective for setting optimal emission reduction targets for society, it is not the appropriate basis for developing policies and regulations that can incentivize the private sector to abate emissions to such an extent that the socially optimal reduction target is actually met. Instead, it risks giving the wrong impression that abatement is possible at low cost or even at a profit, and therefore would happen voluntarily without a need for regulations. What we must acknowledge is that the cost perspective of private investors look very different from societies, cost perspective, because the private investor will operate at a much shorter time frame, pay a higher interest rate, and be more risk averse, and therefore operate more on the basis of observed energy prices and known technologies. And with this perspective, methane abatement costs come out much higher, and with fewer opportunities being profitable. And recognizing this, the regulator who wants to entice or force the private sector to actually engage in methane abatement must make sure regulations are strong enough to outcompete the relatively higher abatement costs experienced by the private investors. In this figure, you see how global anthropogenic methane emissions will be about 450 megaton annually in 2050 in a business as usual scenario. That would be the blue dot to the right. If employing all existing abatement technology that we know of today, we would be able to bring emissions down to about 230 megaton annually. That would be the purple dot to the left. The pathway towards such a maximum technical reduction level can be described by marginal abatement cost curves. So when using a social investor cost perspective, the marginal abatement cost curve would be the orange line. And when using a private investor perspective, it would be the blue line. So starting from a business as usual emissions in the blue dot and moving left towards the maximum reduction in the purple dot, we follow how first the profitable and low cost opportunities are realized before proceeding to the more expensive ones where the curves go above the x-axis. So the orange line shows here that with a social cost perspective, about 70% of the technical abatement potential available can be realized at no cost or a profit, so they are cost effective. But if we instead use a private investor perspective described here by the blue line, only about 25% of the full abatement potential will be seen as profitable by the private investors. So the take-home message here is that for effective regulation of methane emissions in the private sector, regulators must start from a private cost perspective, because starting from a social cost perspective will understate the policy ambition needed to get the private sector started on abatement. So what other implicit assumptions than the cost perspective matter? Well, the cost curves that are drawn here, they also make implicit assumptions that markets work according to mainstream economic theory. That is, that markets are always clear and that in the long run, there will be no profit made because as soon as there is a profit in the market, new investors will arrive who will take market shares by undercutting the price until any room for profit is exhausted. But we know that real markets are much more complex than that, and that companies and whole industries keep making profits year after year. And this is, among other reasons, because there are natural as well as legal reasons for barriers to enter markets. And a sector where this is particularly apparent is the oil production. So coming back now to what Drew showed us previously, I will continue a little bit on that here. Because what this shows here is that for oil production, where we have seen very high profit margins sustained over decades, this is also a sector for which existing technology can achieve very large cuts in methane emissions at low cost or even at a net profit, if the vented or leaked gas is actually recovered and sold. But here, the high profit margin from production will act as a barrier for investors to engage in methane abatement when the profit margin for production outcompetes the profit margin from abatement. And this figure here illustrates how the profit margin from oil production, which is the orange range, outpaces the profit margin from recovery of gas, which is the lower green range, as the world price of oil goes from historical low, which we saw in January 2020, to a historical high, which we saw in July 2022. So when prices were low, profit from abatement sometimes outpaced profit from production, and there would have been good incentives to voluntarily invest into methane recovery. But at higher world market prices for oil and gas, the profit margin from production quickly outpaces the profit margin from gas recovery. And then we should not expect profit maximizing oil companies to be interested in methane abatement unless they are forced to by legally binding and strong enough regulations. And the blue range that you see here reflects the profit margin from gas recovery when we put a fee of $1,500 per ton methane emitted on oil producers. So similar to the fee that has recently been proposed for the US oil and gas sector. Will it be strong enough to drive methane abatement? Well, according to this example, yes, as long as the world oil price stays below $80 per barrel, but likely not for higher oil price levels. So the take-home message here is that for effective abatement, regulators must be aware that high profit margins in production can sometimes outcompete profit margins in abatement, in effect, bar abatement. And to overcome this, any penalty fees on emissions must be set high enough to make profit from abatement outcompete profit from production. Or alternatively, we can implement binding technology standards that simply force uptake of existing, mostly low-cost abatement technology in oil production, which would reduce up to 90% of emissions in this sector. Thank you.
Thank you very much, Lena, for ending that with some perspectives about financial incentives to methane abatement. What we'd like to do now, to also thank Drew and Thomas for setting the scene to today's discussions, we can move over to discuss some of these key points. And now I'm pleased to welcome our expert group of panelists joining us today. So a few words to introduce you all. First up, we have Martina Otto, Head of Secretariat at UNEP, the United Nations Environment Programme for Climate and Clean Air Coalition. A few words about Martina. She brings over 25 years of experience in environmental policy and program management with a focus on creating sustainable cities. She's an expert in partnership building and has held multiple roles at UNEP in both Paris and Nairobi. And she was a previous head of Secretariat for the Global Alliance for Buildings and Constructions. Before joining UNEP, she worked on trade, environment, and economic for environmental protection at the UN Conference on Trade and Development, and is a qualified lawyer specializing in environmental law. A warm welcome to you, Martina. Second up, our second panelist, we have Professor Marcelo Mena, a distinguished professor at the Pontificia Universidad Católica de Valparaíso and founding chief executive officer of the Global Methane Hub based in Chile. We're pleased to have you here. A few words about the Global Methane Hub. It's the world's first and only globally coordinated philanthropic effort to overcome barriers and slash methane emissions in record time, with methane reduction policies and projects in over 150 countries and territories. And during his tenure as the former Environment Minister for Chile, Marcelo was instrumental in numerous international environmental initiatives, with most notably his involvement in crafting a groundbreaking agreement aimed at phasing out coal power generation. He also pioneered South America's inaugural carbon tax for power generation, and has spearheaded efforts to safeguard over 1.3 million square kilometers of ocean. So a very busy individual. And finally, and last but not least, I'm pleased to welcome Professor Euan Nisbet, an Emeritus Professor of Earth Sciences from the Royal Holloway University in London. So Professor Nisbet's work is expansive on atmospheric science, where he specializes in studying methane emissions and their impacts on climate change. He's led numerous international research projects and has been a key voice in climate science, influencing both policy and public awareness. He also leads MOIA, the Global Methane Budget, a UK NERC, a Natural Environment Research Council consortium, with 14 partner institutions studying methane across the planet. Throughout his career, Euan has contributed significantly to understanding greenhouse gases and global warming, and his dedication to environmental research continues to inspire new generations of scientists. So a huge warm welcome to all of you. Welcome, Martina, Marcelo, and Euan. We thank you for joining us today. So to get us started, I'd like to ask each of you an opening question as sourced from the questions that came in from our audience prior to this deep dive. So I'd like to start off with you, Martina, if I may. So given the urgency highlighted in both the article and today's presentations for stronger policy-led actions to reverse methane emissions growth, how has the Climate and Clean Air Coalition working to enhance global methane mitigation efforts, especially in aligning finance and policy across different countries?
Okay, fantastic. Thank you, Gilbert, and it's a real pleasure to be here with you. And thanks for the question, and you're absolutely right. The urgency is really well established, both from a science perspective, but also from a political perspective, with the Global Methane Pledge that has seen the light of the day, and for which the CCAC is also providing the Secretariat service. And maybe I should say one sentence about the CCAC, who we are. You mentioned it, we're hosted within the UN Environment Programme, but we're a partnership of over 180 constituencies coming together, basically, over 90 countries and over 90 non-state actors with international intergovernmental organizations and NGOs being part of the group. And we really see each other as the coalition of the working and really thriving, taking things forward through partnership. Now, you asked the question on the aligning finance and policy, and we really need to take the pledge to action. The goal that has been set with the pledge needs to be translated into really action points, the ambition translated into policies and regulation, and this complemented with financial support. And we got a bit of data already on this that we don't quite know how much is actually really spent. But numbers that we had out there, and thanks to actually a study that Marcelo financed, we did say that the sector would, that methane action receives less than 2% of global total climate finance flows, and that despite these outsized warming and development impacts. And so with the methane finance sprint that we saw last year, we got a bit more on this, but it's definitely far too less with regard to the opportunity that we have. Now, in the CCAC, we're tackling the challenge through 3 key avenues that are in line with our 2030 strategy. And the first is really coming from the science side. Decision makers need the confidence to take action. And well, Drew, you mentioned it, is the chair of our scientific advisory panel, and the global methane assessment that we put out that gave rise to the Global Methane Pledge actually gave a lot of not only food for thought, but really information on focused measures. So that helped to focus the attention. There is more to come. We do similar efforts now for really drilling down on the agriculture sector, but also in making the economic case for action, because we thought we needed to fill a gap here. Another gap that we're filling is with our technology and economic assessment panel, where we really look into innovative, interesting, but underinvested in technologies, and bring information that on business models and what works by typology or archetype of countries, to see that we close that finance gap. A second strand of work that we have is on the political convening and the advocacy. And here I really want to highlight, for example, the ministerial meeting that we just had in New York, coming on the heels of the Pact for the Future. And one of the key points was that we need to make sure we integrate methane action very visibly into the NDCs. This round is really decisive, coinciding with the 2030 timeframe of the Global Methane Pledge. and really seeing the NDCs as investment plans, because they give a strong signal both on the ambition in the countries, but also on the measures that the finance sector needs to have on the radar. We do work with the finance players as well. One is about stitching together different funding streams. And I think Lena gave us a really good indication of why that is needed, because the benefits are sometimes not necessarily there where people need to put their hands in the pockets. It's also about coming up with the criteria to show the methane content in different actions in official development aid as well, and really direct finance flows. And maybe I'll leave it on the finance side at that. And the last bit is really on our capacity support. We have a trust fund for which we support countries directly. Everything we do is country driven. And we have efforts on planning with 33 methane roadmaps underway. We support over 35 ODA eligible countries with NDC enhancement projects. So really making sure that we have these investment plans in place. But we do also concrete activities on the key sectors. So for agriculture, for example, supporting 22 countries, empowering national leaders like Brazil, our new co-chair, in livestock action, sector mitigation plans on tropical agriculture, and so on. We do a similar effort around waste with 21 countries, looking at landfill regulation, MRV enhancement, MRV standing for monitoring, reporting, and verification, looking at waste valorization, and really looking there as well at some innovative technologies such as like soldier fly farm and so on, to really catch issues not only at the end of landfill methane capture, but also earlier on in the avoidance and diversion and revalorization of organic waste. And the last bit is really on the fossil fuels. And I think both Drew and Lena said it so well, and Tomas as well, so well. We absolutely need regulation in the sector, because otherwise the money is not flowing where it needs to flow. And that's why we've set up a fossil fuel regulatory program to help up to 20 countries with the first cohort, Iraq, Ghana, and Kazakhstan, to get us started. And that builds on work that we've done in the past in Nigeria and Colombia and others, really on regulation to set the right framework. And maybe with that, I stop here, but it gives you a picture of the breadth of the work that is being done to bridge this gap between, well, the knowledge, the data, the science via the policies to actually get the finance where it needs to be. Thank you.
Thank you very much, Martina. That was very rich, and I've got some great keywords that came out from the CCAC, which will be good to uncover and explore slightly later on advocacy and a regulatory framework on fossil fuels for methane abatement. So let's move over, and I'd like to bring in Professor Marcelo Mena Carrasco. So we heard today about the critical role of rapid methane reductions alongside CO2 decarbonization. Let's talk a bit about the Global Methane Hub. How has it been leveraging philanthropic support to optimize methane abatement strategies globally, and particularly in sectors with significant mitigation potential like fossil fuels and waste?
Great, thank you for the question. Yeah, so the Global Methane Hub was put together when the Global Methane Pledge was launched in November 2021. We started operations. I took on the job in February. Since then, we're a global team, have staff in all continents. It's a science-based organization and evidence-based organization, and many of the people that are part of the team have actually a strong record on meaningful policy gains based on science, including the net zero for Chile, and people like Hayden Montgomery, who helped put together the Global Research Alliance on agricultural greenhouse gases. And so we bring a lot of that. And we're based out of Santiago, Chile. 80% of warming is from methane is coming from the Global South. So it's good to be there fostering South-South collaborations. Since we started, we've delivered over $200 million in funding and have recently gotten financial support to continue until the end of the decade, which is great because this is a sprint that we need to do on methane mitigation. So the nature of the sectors really changes the way that we approach them. And we're working from the top with CCAC to establish mitigation targets, hopefully on NDCs. In the case of supportive groups like IMEO, we'll help them look into the methane response system. And we'll continue to help the implementation of the methane supply index for those who have followed the EU import standards. It will be key to establish which different oil and gas sources can access the European import market, and therefore this methane supply index, which will be related to methane sat being launched, will be a really key important place for that. Also, we're working with countries to provide technical assistance to address methane leaks. And we also work with communities to help drive change, including those who work on the health impacts of oil and gas extraction. Of course, also, it's important to look in the indoor air quality benefits of electrification. And so therefore, we're working with groups like Stanford University and a network of different groups in Latin America to look at those indoor air quality problems with natural gas use. In waste, we're working to make those emissions visible and working with multiple NGOs to set up something called the waste.map. And the new observations from the Tanager satellite will really open up a new world of awareness on waste emissions, which can be mitigated. And also we work with NGOs to promote regulations such as organic waste diversion, emission standards for landfills, or food loss and waste prevention through food banking, for example. But also, finally, on agriculture, it's important to talk about the way that we present this. It's really important to have farming communities be the allies, because they are the frontline communities tackling climate change. And so we work starting with bringing benefits to farmers. In this case, the feed ration formulation tool is a really great way in which we're working in multiple jurisdictions and helping improving the feeding and looking for lower emissions combinations of formulations, but also looking into rice production improvements. And since mitigation in agriculture, which is in this paper, is not addressed in a deep way, we're trying to open up the playbook with the enteric fermentation accelerator, which will look into providing breakthroughs such as methane vaccines, feed additives, genomics. And it's the first concerted effort looking into tackling this. We've had billions of dollars looking into clean technology. We've had very little funding in the single largest source of methane, which is anthropogenic methane from livestock production. And we will look to expand these breakthroughs in rice research because there's many things that we need to achieve, reduce the emissions, but also looking into lower water use conditions in which we will be able to promote issues like aerobic rice production with the corresponding adaptation benefits. And on finance, just final comment, we are looking into overcome this 2% gap that we have, only 2% of climate finance going to methane mitigation, and trying to overcome market barriers. We're working with the Climate Bond Initiative to look at ways to unlock funding in the oil and gas sector methane leaks being addressed, because it is 1.5 aligned, and many partners do not want to invest in this because it might be seen as investing in oil and gas. We're also working with MDBs, and we've helped leverage billions to billions in programs with groups like the World Bank, IDB, and IFED. So that's what we're trying to do, and glad to work with those participating here. And we're very thankful for this paper, which really provides great guidance on where to look into invest in the future.
Thank you very much, Marcelo, and congratulations with all the great accolades that have come out of the Global Methane Hub. That is truly impressive, and it shows a lot of hope for what we can do in this space. So last and not least, I'd like to now bring in Professor Euan Nisbet to dovetail off what Tomas was mentioning before about the importance of data and its resolution specifically for methane tracking. And the question that I'd like to ask you today would be, so we've heard that satellite technology can significantly enhance emission monitoring. And just last week, the Carbon Mapper released the first methane and CO2 detections by the Tanager-1 satellite. So in what ways do you think satellite data can be effectively utilized to verify and guide national and international methane reduction efforts in line with the 3 imperatives outlined?
Yeah, that's a pretty important question, because you can't actually regulate it until you can measure it. And measuring it is, there's good news here. It's getting an awful lot better and quicker and faster and cheaper. There are really huge advances being made. Now, I'll talk about them. The most spectacular ones, obviously, are in the satellites. And I'm actually African. And the good thing about satellites is you have world coverage. You can go anywhere. nearly anyway. But there's also a lot of, I think equally, perhaps more important work being done on the ground or close to the ground, looking at smaller emissions, both with vehicles you just drive around, just an ordinary SUV loaded up with a bunch of instruments. It's not terribly expensive, and drones and light aircraft. So let's start with the satellites. They're really getting superb at seeing hotspot point sources. And in many things, not just methane emissions, the really big sources are disproportionately important and disproportionately easy to do something about. So huge sources everyone's familiar with are gas leaks and things like that. It's not just that, it's landfills. Huge tropical landfills, particularly in places like India. I grew up in Zimbabwe, and quite close to my school, there's a landfill that's frequently on fire. All you need to do is cover it with a bit of soil. It's not very high tech. Sorting out landfills properly is still pretty cheap. So the satellites are capable of nowadays spotting emissions up to a few hundred kilograms an hour. Sorry, down to about a few hundred kilograms an hour. So that obviously picks up the really big gas wells, which are generally very economic to fix anyway, but also smaller wells and landfills, big urban landfills. And we forget nowadays, many of the really bad landfills are in the tropics. If you look at the UK, they very dramatically cut their landfill emissions over the past 20 years with very little extra cost. It wasn't a political issue, it was just done. And the impact was huge. Doing that, this is not high-tech stuff. And you can turn the landfills into electricity sources and so on. Doing that, particularly in India, but also in parts of South America, a lot of Africa, and a lot of East Asia, is pretty cheap. And you can spot those big ones with the satellites very fast. There are nowadays quite a lot of satellite mapping of hotspots. Satellites are also scientifically pretty good because they're good at mapping out regional enhancements to methane. And this is the big tropical wetlands in particular that we're very frightened about, that their emissions appear to be going up. Places like the Sud in South Sudan, or the Pantanal in Paraguay and Brazil and Argentina. So that's important. Now, on the ground or closer to the ground, there's lots of developments going on here. I mentioned putting instruments in SUVs. For example, one of our students, Julie Fernandez, she mapped all the main streets of Greater London for gas leaks. All these big streets have got gas pipes underneath them, and she found thousands of leaks. Very cheap. It's just one student working for a couple of years, quick, and leaks all over the place. And all you've got to do is put a patch on those leaks. Again, it's not high tech. She mapped Bucharest as well. So this is not difficult stuff, and we can find them. Really interesting nowadays is the use of drones. Two ways. You can fly an instrument on a drone, but that's quite a big instrument. Sorry, a big drone, because the instrument's 5 kilograms or more. Another way of doing it is to mount a mirror on the drone and then bounce light off it, or else use the drone to collect a bag. And that way you can tell whether it's a landfill or a gas leak or something like that. You can use light aircraft for this too. So my general message is that measuring methane emissions is getting better very rapidly. The technology is going to be accessible worldwide, and that countries should now be declaring their emissions as measured emissions, not modeled emissions. There's Goodhart's law. When a measure becomes a metric, it ceases to be a measure. And quite a lot of our emissions declarations for the Framework Convention on Climate Change, I think, are increasingly far away from the actual real amount of methane that gets in the air. We're getting to the point where we can do accurate measurements pretty cheaply. I think it's within the next 5 to 10 years all over the world, in any country that hasn't got a failed government. Once you know where the emissions are and how big they are, then you can stop them. So I'll stop there.
Thank you very much. That's very enlightening. It's a great way to actually seg into our Q&A. So we've, Euan, you've spoken a lot about landfills and methane leaks in agriculture, which has also been a huge focus of the major contributions that we can see for us to focus on methane imperatives. I had a couple of questions come in that I'd love to open up, and maybe to start with you, Euan. And it's from two audience members, William McDowell and Barbara Winecker, if I pronounce that correctly. And it's about other sources of naturally occurring methane. We speak also about biogenic wetlands, permafrost, tropical coastal aquatic systems. Question is, and I've put these two together, to what extent does better quantification of largely natural sources of methane, as I've described, play in documenting the importance and effectiveness of methane mitigation actions? And also, is it possible to estimate the level of this climate change-induced methane release from these natural resources?
Yes, complicated question here. We've got very good reason to think that the natural emissions of methane are increasing strongly, particularly in the last few years. And we can tell that by measuring the, NOAA in particular have a network around the world of measurement stations. And we also use the carbon isotopes. That's the difference between carbon-13, which is a little bit more in the fossil fuel methane, and carbon-12, which is a little bit richer in biological methane. And from this, we can try to extract what the natural emissions are. And we think they're going up pretty fast. Now, as they go up, they essentially remove our emission space for anthropogenic methane. It increases the need to decrease anthropogenic emissions. So if natural emissions are going up strongly, and that's a climate change response, as you get a warmer world, although some areas become a lot drier, and I'm talking of Zimbabwe, much of the world gets wetter. A warmer world is a wetter world. And so areas like the Sud, for example, at the moment, there's been very, very heavy rain across the whole of North Africa. Sorry, the whole of moist North Africa, the Sahel. And emissions from wetlands are going up strongly. Now, there's a bit of a problem in the tropics. We think much of this is coming from the tropics at the moment. We strongly suspect that the northern wetlands in Canada and Siberia are going to be turning on fairly fast too. But a cow is a walking wetland, so it's a bit hard to tell between a cow and a wetland. In the tropics, in many areas, there are more cows as well. If you get warmer, wetter world, you get more cows too. There are plenty of things we can do, particularly in the tropics. I mentioned landfills. Another very important thing is crop waste burning, and also deliberate grass fires. These produce enormous air pollution right across Africa and also in India and Southeast Asia. They're pretty easy to stop. Again, I mentioned the UK example, and Europe had a lot of crop waste burning in the 1970s and 80s. That's pretty much stopped now. You burn it to electricity, or else you use different agricultural practices. There's a great deal we can do. But the more that natural goes up, natural emissions go up, and they're doing that, and we're not able to stop. We shouldn't stop that because natural wetlands are incredibly precious. That means there's even more reason to bring down the anthropogenic emissions.
Thank you very much. That was very clear. Does anyone have any thoughts they would like to dovetail off Euan's interjection there? No? Okay, then. Thank you very much for that. I'd like to now move on to a question that's come up quite a lot, actually, and it's talking about the alignment of methane and CO2 mitigation and the interplay between them, which I think is going to be a source of a lot of discussion, and in the broadest context possible. And this is very much open, potentially. I'll start with you, Drew, actually. I think you'd be a great person to start with. This is from someone called Matthijs Harmsen. And his question is, how can we ensure that an increased focus on methane mitigation doesn't lead to reduced CO2 mitigation efforts, potentially hindering long-term targets? This seems to be a real risk for countries with a greenhouse gas NDC target that aren't gas specific.
Yeah, thank you. And thank you, Matthijs. That is a great question. I think one of the things that we have to keep in mind is there's always a tension between trying to put things on the same scale to allow comparison, which we do using something like GWP, right, as part of the Kyoto Protocol. And ever since then, it's been part of UNFCCC and NDCs. And the reality in that not all of the greenhouse gas emissions are fungible, right? And so one of the things I was trying to show in my presentation is that the methane is our strongest leverage by far over climate change in the next 30 years. But CO2 is the strongest leverage over climate change in the latter half of the century. And of course, you know, there are different benefits for public health, right? Methane directly makes ozone. Many CO2 sources emit particulate matter, which is another, you know, driver of poor air quality. So there are severe limits to just using a metric and comparing them. That said, you know, the comment is correct that within NDCs, this is often how countries do this. But I think a more sensible approach, and something we in the CCAC and others have written about, is the need for policies to emphasize these kind of twin aims of reducing near-term warming, because, you know, people are suffering from this right now. It is not some long-term future thing. The fires, the heat waves, the hurricanes, they're now. And we need to reach net zero, right? There's just no hope of meeting any of our climate targets till we get to net zero. So we need a target that gets us, we need to really hold countries to following something like a trend towards net zero, which is something that many countries have pledged, and really which refers to CO2, or perhaps CO2 plus nitrous oxide, because those are both very long-lived. And they need to be following targets like the Global Methane Pledge, which separately, but substantially put them on trend trajectory towards reducing their methane. So I think it's a very sensible caution that we don't allow countries to, you know, do one at the expense of the other. They really have to do both. Thanks.
Absolutely. As detailed in the lead article itself. Any other panelists would you like to share? Yes, Marcelo.
Yeah, I also wanted to, because it's something that comes up a lot for us too. This is not a replacement to carbon dioxide mitigation. And actually, if anything, the methane agenda allows you to see invisible impacts that are additional to fossil fuel use. So you'll know, for example, that leaky methane oil and gas sources may make the transition to natural gas more questionable and less addressed. And you know, we've seen time and time again that real emissions are higher than self-reported emissions. And it also, we see that, for example, the now recent research on LNG slippage in ships, right? So we see the full LNG impacts that we wouldn't see individually. We'll see the additional impacts of methane in the coal emissions, and also the secondary impact to steel production. So it makes us gives us more evidence to actually decarbonize steel production faster, because we know more. So I think it is compatible. But what you guys are saying is really true. Methane specific targets are better. We also need to know what NDCs mean in terms of short-term mitigation of temperature, right? So we could go for decades talking about GWP 20 or GWP 100, but what really is important is what will the measures that we take today mean for short-term temperature rise and tipping points. And I think we owe the policy community answers on how to make that simple. And finally, there's no 1.5 being alive without methane mitigation, and so therefore it is the fastest way that we could reduce temperature in the short term. And when we say 1.5 alive, as a motto of the Methane Hub, it's not only about that we need it to reduce and keep 1.5 alive in terms of a temperature reduction, but as a matter of fact, if we do not have temperature reductions in the short term, it'll be very difficult to sustain a Paris Agreement that will only yield benefits towards the end of the century. So politically, it's really important that we deliver the world the temperature reductions that we need in the short term.
Maybe if I could come in quickly as well on the specific point. we've just put out guidance on how to integrate super pollutants. So that's a category of which methane is a part. How we can integrate those into the NDCs. And we've just run a whole series of regional events together with UNFCCC, the Secretariat, and the NDC partnership in different regions on how to do that and why is it needed, but really how to do it. And one key element here is that while we look at the commitment is a nationwide target. So there is one big target where you can agglomerate different things underneath, but then how to show as well the different actions that actually flow or have flown into the process to determining this target. And the more detailed that is, and here some countries have set a really nice standard. Japan is one, for example, really spelling it out with targets and measures and so on. And that doesn't have to be in the NDC directly. That could be put into planning documents that accompany and are there for transparency reasons. But the more precise that is, the more that becomes a way to show the ambition, to show the direction of travel, that shows as well the longer term decarbonization objectives and the near-term warming objectives. And the more we are clear about that, the more it gives a signal for the finance sector. And I think that's really a way to play with that a little more. There's a few measures that help our stepping stone. We heard some where it may be actually difficult as a storyline, but if we say methane capture from landfill, that's part of a transition. And I think here teasing out those narratives, I think is really helpful and important as well to show it's not either or, but it's both. And while one is the steeper change and is a bit more difficult, the other has these more short-term possibilities as well. And maybe their circularity we talk, that's the equivalent in the fossil fuel sector to the decarbonization, the just energy transition. If you look at circularity to reduce waste overall, but including as well organic waste, and here we come with some measures to help reduce food waste, which is actually motivated by something else as well, and that is food security. So really teasing that out, I think we get the narrative right, that it's not directing things away from what needs to happen, but that it's clear that it's both. Over.
Thank you. So just find my unmute button. Thank you very much, Martina. I'd like to now bring Lena and Tomas into the discussion, talking about enhancing policy and economic instruments here. So maybe this first one is for you, Tomas. But yes, Lena, if you'd have any thoughts on this, it would be great. So there is the Durud Zalke's policy outlook that was published as part of the hub. That suggests that to speed the shift to mandatory methane mitigation, the EU and other major purchasers of natural gas could form a buyers club that sets a methane standard equivalent to the soon-to-be-announced EU standard. How could this be structured, and what international cooperation models could enforce these standards effectively? Tomas, would you like to share your thoughts?
Yeah, absolutely. Very good question. Indeed, we are seeing increasing interest not only from the European Union, but also from Japan, Korea, and other major fossil fuel importers. We've seen, for example, the launch of this so-called CLEAN initiative to look at methane and other greenhouse gas emissions from LNG trade from Korea and Japan. And I think there's certainly, it's a space that is growing in attention, and there's a lot of opportunity there, because when you think about methane emissions from these countries, it's mostly from imported energy. So there's a lot of scope for them to act through their trade and by encouraging their trade partners to take action. And there are different ways to do this. A standard is one of them. It's what we're seeing in the EU regulation. The EU has a program called You Collect, We Buy, which is essentially a different way to encourage some of their trade partners to come up with projects to recover gas and then sell and place it in the market. And this is a way to increase also energy security. So it's quite interesting in that sense. But let's focus on this idea of a methane standard. I think the key issue there is agreeing upon a common way to measure and track methane emissions throughout fossil fuel supply chains, so that you have credible, accountable ways to calculate emissions, set the standards, and control the standards. And the European Union's regulation references the Oil and Gas Methane Partnership 2.0 standard, which is an international standard for the oil and gas sector, which is led by UNEP. Perhaps Martina, I'm not sure if she wants to come and talk a little bit about that. The UNEP is also working on a standard for methane from coking coal used by the steel sector. It's still work in progress, but there are references out there that can be used for this. And it's essentially a matter of coordinating these different actors, getting together and agreeing upon the standards and how the regulations will be put in place. But let me finish with one final note. While we are seeing the next years a kind of the market for natural gas in specific, but also for oil to a certain extent, and coal will be easing with a lot of new supply coming online, and it might shift a bit to kind of a buyer's market. And that's some of the messages that are come out just today in our World Energy Outlook. And this would then facilitate this kind of measure from buyers. We should not forget that some of the producing countries face challenging contexts, and they might very well need help. And instead of only working on kind of providing a stick and say you need to deliver with this standard, it's important to provide some carrots as well, to provide technical support, to provide support for regulatory development, for oversight, to ensure that they can work on compliance, and that they have all the tools and resources they need to deliver these emission reductions.
Thank you very much, Tomas. That actually leads very nicely to a final point. Lena, I don't know if you have something to share with that, but
I think it was quite exhaustive what Tomas was saying. So please.
I have a final one then for you, just to close this off, because we received a lot of questions about empowerment in the global south and how they can be integrated and be incentivized to engage with methane abatement. So a final question, it's for you, Lena, and it's from someone called Kwabena Fosu Amankwa. And what she shared was, looking at the results so far shared, the contribution of African countries to the global methane burden is minimal. Do you think it is economically prudent for African countries to invest in methane abatement, considering the economic challenges of the region and the very pressing issues on reducing poverty? It's more of a very high-level question, but would you have any thoughts on that?
I think it's an extremely important question, because if we don't solve that, then we will not get very far, actually, with the and for Africa, I think the most important sector there would be agriculture, and we have and there it is very important to understand the local context that we are and I'm particularly thinking about the pastoralist communities, because this is a very large source actually of methane emissions, and at the same time this is a region where we have nutritional needs still need to be met. So there are regions where livestock is a very, very good source of high quality protein. So it's really important that that these communities also get support, because we also have to remember that these communities, the pastoralist communities in Africa, are already quite marginalized politically and economically, and vulnerable in different ways. So if we don't support these communities where they are now, and the kind of needs, for example, we can think about improving the health of animals through vaccination, and but also improving the the risk management possibilities in the communities, for example, by storing feed and for bad times, in particular in situations where we have climate change worsening. And if we don't support them where they are now, their vulnerability will just increase. And their options for alternatives will just narrow even more. And if they don't have any options to act, they cannot also contribute to good solutions also for the even for climate change, because these communities know very well what works and what would be sustainable, but they need to have the possibility to act and have the alternatives available to them.
Thank you very much, Lena. That's a very empowering note. And I see that both Euan and Martina have a few words. What I'll do is, just in the interest of time, let's save this for when you give your final comments, which we'll leave on to now to impart your wisdom with our audience, if that's okay. Because I'm acutely aware we have 3 minutes until we close off the session. So thank you very much to our speakers and our panelists. I think we could have gone on for a while. That was just literally the tip of the iceberg in terms of the questions. We had some fantastic questions come in. So I'm really sorry to the audience if we didn't manage to. I tried to collate them. But nonetheless, I would like to have each of you share 30 seconds, a couple of sentences, your takeaway message to the relevant scientific communities, agencies, or policymakers in your own words. So let's get started with Euan. What would you like to share?
Okay, well, taking up that last point, Africa, I'm African. I've walked over north to south across Africa and a good bit of West Africa too. Africa can do a great deal. There's been enormous deforestation since I was a child, and you see these huge differences in places like Zambia. The crop waste fires are huge. Yes, there's a lot of pastoral agriculture. That's actually replacing natural antelope. There's probably been very little difference in methane emissions. But Africa can do a lot, and particularly with landfills, crop waste fires, lots. So it's if you look at Europe, it's actually doing a very good job on reducing its emissions. It's time now for Africa, India to play their role. So I think it's Africa's turn to do something.
Thank you. And Martina, you also had something to share, so over to you.
Thank you. Yeah, I also wanted to comment on the agriculture piece, and maybe just to say as well for the low and middle income countries, waste is always a problem as well everywhere, and there's opportunities that we can turn around. And that's really the thing, that we look for the nuggets as well, where it actually contributes to sustainable development. We know that climate hits the most vulnerable most, and the same goes actually for air pollution. So there's a direct correlation here as well, and that doesn't mean we cannot do anything, but we have to actually find the right ways forward. And for agriculture, I wanted to highlight that we also need to invest in solutions that we know, and that is productivity improvements. And there's a lot of room without going overboard and being totally intensified and whatever, but sustainable intensification is the key word here that we can do in low and middle income countries. And that then contributes to food security as well. There's something in it for the farmers and so on. And the pastoralist communities, they know very well, I mean, where we are right now. They used to have their herds as their treasure box, in a sense, treasure box on feed. But they know when droughts are coming and they lose their cattle. So it becomes an adaptation measure to turn things around. And if they can tap into methane abatement money to change their system, then let that be the case. And I think that's maybe a good way to see it, to tap into funding. And what we do with Brazil, for example, as well, there's something really interesting on connecting that with avoidance to encroach into natural land. And we have something that's called digital extension services, which is rather interesting, because it helps on the one side the data situation that we alluded to earlier, but it really provides concrete help for farmers as well. And I think the more we look for those opportunities, the more there's something in it for the low and middle income countries. Over.
Wonderful, Martina. Very hopeful last few words. Thank you very much. Tomas.
Thank you. I want to finish bringing your attention to the fossil fuel sector, where we have more than half of the abatement potential currently. And it's where I've been dedicating most of my attention for the past 4 years or so. And in this time, while we have seen stubbornly high methane emissions, we have also seen growing momentum for tackling these emissions. And we have seen some success stories in a few regions and a few countries. And I'm quite hopeful that we will go from growing methane emissions and growing momentum to tackle these emissions to growing momentum to tackle these emissions and declining emissions, because we are now in a place where we have enough people, enough companies, enough countries engaged in these reduction efforts, that if everyone continues to contribute, there's a good chance that we will be able to revert the trend in emissions. Thank you.
Thank you very much, Tomas. Lena.
Yeah, so I think the good news is that we have quite a lot of knowledge about what can be done. And I think the work that we still need to do now is to take this down and adapt it to the sector level, to the country-specific circumstances, to the local context, to understand also these groups where we want to see these solutions implemented. What are their drivers? Where can we meet them? And creating the right incentives to actually drive these changes. Thank you.
Thank you, Lena. Marcelo?
So when we talk about methane mitigation, we also like to say that the benefits stay where action is taken. And in many ways, we've engaged countries that don't even have the methane pledge on top of their agenda, because we're trying to help solve something that's important to them. For example, low yields in agriculture production, in which we provided win-wins, so that contribute to food security. So improved feeding will actually improve output and improve rural livelihoods. Improved waste management will, for example, in the case of adaptation and higher heat waves, will lower the risk of a dump fire that it's on top of the political agenda when these occur. And this happens many places, including India, for example, in which we're able to establish relationships with multiple jurisdictions. And so I think that's probably the biggest thing, that we could actually talk about this, because what we do, this I think is the Global South contribution to mitigation through development. I think we need to look at it in that prism, because that's probably the way that it's going to stick. And it will not depend on the political support, but actually from the benefits that are actually brought to the communities where this is taken.
Thank you very much, Marcelo. And last but not least, as also a thank you to Drew, who inspired this session through his article. What would you like to share?
Thank you. Yes, I want to share two last things. One is that what needs to be done is really very specific to where you happen to be. And some areas have lots of abandoned coal mines and gas wells and fossil fuel infrastructure. Some have none. Some parts of the world, our consumption of red meat is 6 times what the WHO recommends for healthy levels. In some areas, it's too little. Right? So dietary change is important in some places and not in others. Waste is one of the few sectors where emissions does not closely correlate with overall economic development, because some countries that are well off have done it well and others haven't. So there are examples out there, but they really need to be tailored. And what to me is exciting is that, if I think back to even 2020, methane was barely on the political agenda. And now we've got over 150 countries signed on to the pledge. So we've really taken a great step forward. And now the next step is to get beyond pledge to action. And I think especially this new, we've heard from many of the panelists in this great discussion that you can't regulate something and mitigate it unless you can measure it. And this revolution of our ability to measure things is really enabling that next step of going from the pledge to actual mitigation. So I want to leave you on that cheery note. There's still a lot of work to do, but I think we are about at the stage of having the capability to get it done.
Wonderful. That's a really great way to summarize the outputs of our discussion today. Thank you so much, Drew. And we have run over time, just about 5 minutes. I'm sure we could have continued this for a lot longer, but I'd like to say a huge thank you to all of our speakers and expert contributors, Professor Drew Shindell, Tomas de Oliveira Bredariol, Dr. Lena Höglund-Isaksson, Professor Marcelo Mena, Martina, Otto, and Professor Euan Nisbet. Also, thank you to everyone who attended today. I really hope you enjoyed the session as much as I enjoyed moderating it. For those who haven't managed to take a look at the actual research itself, please do visit the Frontiers in Science website, read the article, explore the Hubble content. You can continue the conversation on social media using the hashtag Frontiers Forum. And from that, that's everything from me. I'd like to say a huge thank you. So can I ask all panelists to say goodbye and wave to our audience? Thank you very much for joining. And yes, wishing you all the best for a pleasant morning, afternoon, and evening. Thank you very much, everyone.